Hi Cynthia, I'm going to try doing my presentation in a video form, so try to save a little time here. So my presentation is on the wheelbarrow for simple machines, so hopefully this goes well. Okay, the single wheel cart known today as a wheelbarrow was first introduced during the Han Dynasty of the 2nd century in ancient China. The first person to be credited with the invention of the single wheel cart was Zhu Lang from China in 231 AD. He called it the wooden ox, for it was large in size and capable of carrying a large load of people and materials. The handles faced forward and it was pulled, carrying men and supplies into battle. The oldest mural depicting a single wheel cart recorded was found in the Chengdu Sichuan province in 118 AD. The ancient Greeks of the 5th century BC had a cart for transportation called the monokiklu, or one-wheeler. European historians realized that this style of cart was not invented by the Europeans in the Middle Ages, as originally thought, but had been used in many centuries before. Oddly, there was no evidence suggesting that the Romans had ever used this type of transportation during their development. During the medieval times, the modern-style cart became popularized and used more often. There is not a good description or an accurate time of when they had re-emerged. Between 1172 and 1222, 4 mentions of this style cart were made by an English historian named M.J.T. Lewis. It was found within the 4 texts. 3 names were used to describe the same style of cart. In the 13th century, carts started being used in areas such as farming, construction, and mining. Today they are not only made of wood, as they have been throughout history, but they are made of other metals, such as stainless steel and aluminum, and plastics. In 1998, Hunter introduced the electric motor version of a wheelbarrow that could carry heavier loads with much less effort for their customers. The Eastern design of the wheelbarrow was made with a wheel and axle in the middle of the container for even weight distribution, making it easier for the person handling the cart. This cart was usually pulled, but it was also suggested to be pushed in certain situations. When the Western design was created, the wheel and axle was at the opposite end of the cart, needing more effort to push. The advantage was the lower position of the nose of the cart, making it easier for short trips and loading and unloading the contents of the container. The wheelbarrow had the same design throughout history, with modifications of the container and position of the wheel and axle. So here it shows a few different versions of how they've used different loads and how they're designed. The purpose of the wheelbarrow is for people to have a container that they could lift easily, be mobile, and make their work easier. This is kind of depicting one of the early China ones with the wheel and axle in the middle and being pushed or pulled in a direction. Sometimes it would hold materials for battle, and sometimes it would push people as well. The difference between the Eastern versus Western design was in the Eastern it was pulled and pushed by a person. The wheel was in the middle of the cart, and it was used to transfer people and materials, like I just said. The Western, it was pushed by a person. The wheel was at the opposite end of the cart as the person. The lower position of the nose of the cart, and used primarily for just materials. There are 3 parts of a wheelbarrow. It's a lever, the container, and the wheel and axle. So this is a lever, the container, and the wheel and axle. The handles are considered where the effort comes from, where the person applies the force in the wheelbarrow, like here. The container is where the load or weight is held, somewhere in the middle. And the wheel and axle is the fulcrum of the cart, which is the point of support on which the lever pivots. This would be here. The resistance is between the handles and the wheel and axle. The wheelbarrow is considered a second-class lever because the load is between the effort and the fulcrum. Levers are used simply to multiply the force or effort given to the wheelbarrow to lift heavy loads. The equation used to determine the mechanical advantage of a lever would be the output force divided by the input force, which would be effort or resistance. A wheel and axle are used to help the cart move with less friction, making it easier to maneuver by pushing and pulling. The wheel and axle have a size ratio that works with the amount of force applied to the axle and the distance that the wheel covers. For example, if the radius of the wheel is 5 times larger than the radius of the axle, then when force is applied to the cart, the axle does 5 times more work, but only travels a fifth of the distance. When the wheel is turning, it goes 5 times more distance than the axle would if it had no wheel, but the wheel only needs a fifth of the effort applied to it. It makes it easier for people to push and pull it. When these two simple machines are combined, like for a wheelbarrow, the equation is mechanical advantage equals input force over output force, or effort over load. What are the different classes between levers? There's the first class here, which is a hammer, a crowbar, a shovel, where the weight is on one side, the effort is on the other side, and the fulcrum is in the middle. The second class is like a wheelbarrow, or a door hinge or bottle opener, where the fulcrum is at the end, the weight is carried in the middle, and the effort is on one side. The third class is a fishing rod, human arm, or a baseball bat, where the fulcrum is on one end, the weight is on the other end, and the effort is put in the middle. Here is written the mechanical advantage of a lever. So like I said before, the mechanical advantage of a lever is the output force or effort over the input force or resistance. And it's used to multiply force to lift heavy objects. So, for example, if a wheelbarrow has an effort arm, which is the distance between the axle and the handle, of 120 centimeters, and a load arm, the length of the area of the load of the container, is 40 centimeters, the mechanical advantage would be 3. There's no units for this number, for it's considered a comparison between the effort and the load amounts. So here, it has mechanical advantage of wheel and axle. So it would be the radius of wheel over the radius of the axle, and this helps the object move with less friction, and it's easily movable, which is the same thing I said before. But this would be 5 times more than the radius of the axle, like I mentioned. So this is as a compound machine. Same thing. Considered a compound machine for it incorporates both levers and a wheel and axle used together at the same time. And this is the example that I mentioned before. So this is the 120 centimeters for the effort arm length, so that would be the arms of the wheelbarrow. The load arm length is the output force, so it would be effort over load, so 120 centimeters over 40 centimeters, and equals 3. So the mechanical advantage of the wheelbarrow is 3. So in conclusion, any machine with a mechanical advantage greater than 1 will make tasks easier to accomplish by people. When a machine has an output and input that are equal, the effort will be equal to the amount of force applied by the object being manipulated, and the object will either be moved with force by that machine or would need to use a compound machine with a mechanical advantage greater than 1 to complete the task by a person. This shows that people may find different ways of accomplishing the same task, some more successful than others, when a greater mechanical advantage is kept in mind. And those are my references that are probably pretty tiny to see in the camera, but I guess you have a copy of it. So that's my presentation. So hopefully this is good and the video works. So I will be hearing from you. Hopefully I see you around the school. Okay, thank you.